in this video, we're going to look at our sensitivity report from our linear optimization problem. So in the sensitivity report, we need to think this problem as following. So given we already achieved the optimal solution, is there any leeway on our parameters so that we can still keep our optimal solution? So what do I mean by parameters? So the parameters here are following. If I go back to my original setup, this problem, so all those numbers are coming from my questions. So like here, right? And so this first table, all those numbers are considered as my parameters. And so in the sensitivity report, you're always going to get in these two tables. Well, first, we're going to focus on called the variable cells. So the variable cell, all the information here are related to our choice variables, especially how that are impacting our objective function. Okay, so let's look at together. So in this final value column, this is mapping back to our final report. That is our final value. So basically, it is look at when we achieve the optimal solution for my objective function, and what is the value for my choice variables. So we were going to produce a 300 winter jacket and a 100 parkas. And then besides that, we look at the third column here called the objective coefficient. So basically, those coefficients are the one we use to form our objective function. Remember, for our objective function is maximize the profit, and the 9 is the profit per unit for the jacket, and $12.5 is profit per parker. So those are my parameters that is given from the question. So now somebody might be asked, so how about we are able to do some cost saving stuff, and then we are able to end in changing our those coefficient. So maybe the jacket can the profit become $10 per jacket because we are able to save some kind of production cost. Similar for the parker, we can increase it to $14 per parker. So by changing those, will that changing my objective functions value or my optimal choice? 300 parker or 300 winter jacket and 100 parker. So in order to answer that question, we need to calculate a possible range of this coefficient so that we are able to keep the same optimal solution. And so therefore the computer, the Excel, help us to calculating this called allowable increase and allowable decrease for our coefficient, objective coefficient, so that within that range, we are still able to achieve the same optimal solution, 300 winter jacket and 100 parka. So basically for this 0.375, it is if the winter jacket, since it's the increase, right? If the winter jacket is increased by 0.375 within this range, and so my optimal solution for the winter jacket is gonna still be 300. And if if this $9 decrease to $9 minus 0.666 allowable decrease, so within this range, we are still able to achieve our optimal solution by producing 300 jacket and 100 parker. Okay, so therefore, based on what I said, I'm able to calculate a range called the range of the feasibility. So basically, the lower limit I'm listing here, I'm using the objective coefficient minus the allowable decrease. And that gives me a lower limit. And then the upper limit here is using the objective coefficient plus allowable increase, right? Plus this 0.375. So what does this mean is that if my per unit jacket profit is between $8.33 and $9.37, we're still able to achieve the optimal profit by producing 300 jackets and 100 parka. Okay, we can do the same calculation for the parka. So what I did here for my lower limit, I used the objective coefficient minus the allowable decrease. That gives me the lower limit. And then my upper limit is using the objective coefficient plus allowable increase, right? How much they can increase. So for this range, so that means if I are able to, if the profit per unit of the parker is between $12 and $13.5, we're still able to achieve the same optima by producing 300 jacket and 100 parka. So this is called a range of feasibility. Okay, so from this first table, we are trying to exploring the changing the coefficient for our objective functions and to see at what range we are still able to achieve the same optimal solution. Okay, so now let's move on to the second called the constraint table. So for the constraint table, we will first focus on the constraint that are not binding, right? So the constraint that not binding, including the fabric, the number of the jacket, the number of the pucker. So all three constraints are non-binding. That means we did not achieve the highest limit. Okay, so now let's look at this three: the fabric, the number of the jacket, the number of the pucker. Okay, so first of all, the final value, this column, similar as we explained it for the variable cell, this column is literally the optimal solution. After we achieve the optimal solution, what is the value for my constraint? So basically, it's what we're seeing here, right? So the value of this column. So under this column, and then after that, we're going to talk about shadow price later, but we focus on the constraint right-hand side. So basically, the constraint right-hand side is the limit we already able to identify from the question. So what's the limit of the resource? And so as you notice that, so that's the exactly same column value as we set out in the initial question, right? So the quantity limit. So now let's focus on our allowable decrease and allowable increase, these two columns. Again, for the sensitivity report here, it just gives us a range of something so that we can better understand of optimal solution, right? So therefore, this allowable increase decrease become very important two column. You need to know for this allowable increase decrease what they trying to do or what they try to demonstrate about that allowable, right? So for the constraint that are non-binding, as you notice, they had exactly same allowable increase for this case, right? Because you think about the allowable increase is giving us our upper limit. So the upper limit on all three non-binding constraint is 1e plus 30. So we learned this expression in the linear regression model. This e plus 30 is called a scientific expression. That is 1 times 10 powered by 30. So that actually is an extremely large value. So Excel uses this extremely large value to indicating we do not have any upper limit. Okay, but if you look at the lower limit, so when I calculating lower limit, I'm using the constraint right hand side minus allowable decrease. Okay, that give me the lower limit. So as you notice, my lower limit for the constraint that are not binding is exactly the same value as my final value. So what does this mean? So if you think about what happening here is that we try to using this lower and upper limit to identify the fact that at what condition and then my shadow